My friends, good day. A deadly runway excursion today for a Boeing 747 at Hong Kong Airport. So let me tell you, the plane, a 747-400 belonging to Air Act, a Turkish airline also registered in Turkey. It starts with TC, Tango Charlie. So this aircraft took off from Dubai Al Maktoum Airport. It's not the big Dubai airport that everyone knows, DXB, but another one, smaller in scale. It's a cargo plane, but it wasn't carrying any cargo during this flight. So it was on its way to pick up cargo in Hong Kong. So it takes off on the 19th, and then on the 20th, around 4 o'clock in the morning, it's approaching Hong Kong Airport. The radio messages, some of which have come out simply because there are a lot of people listening on the frequency. Aviation frequencies are open. Many radio amateurs listen in, and some websites let you hear air traffic control. By the way, if you're a student pilot, it's really useful for getting used to the radio. So I was saying that during their conversation with the controllers, there's nothing unusual. There's no worry, no stress, no report of any particular problem.
Nine seven eight eight.
This was the first landing, so they hadn't aborted or tried before. So everything was completely normal operations right up until the last second. So the plane is approaching runway 07 left. We're at Hong Kong Airport, and the left one is the one that's furthest north. It's a runway that extends out over the sea, literally, and it's going to land as normally as possible. It starts to brake, and so that's what the report says. So here, the plane starts to brake. We'll jump straight to the reports, and then we'll come back to analyze. The report said that the Boeing 747 went off the runway, ended up in the water, and in the process hit a vehicle. That means it hit a vehicle, and in that vehicle there were 2 people, airport employees, and unfortunately they died. In the 747, as I was saying, there were 4 people, probably the pilot, co-pilot, loadmaster, which is pretty typical for this kind of flight, plus probably someone else. So we have 4 people who managed to get out. When you look at the images, you can see that the slides deployed, which means the impact was quite survivable because the plane exited when it went over the sea. It exited at about 50 knots, so 90 kilometers per hour. 90 kilometers per hour for a plane that just leaves a solid runway and goes into the water. We're in a fairly survivable situation. So it still broke. The crew of 4 people was able to get out, but unfortunately the 2 people who were in the car were taken away by the plane. So the vehicle was carried away by the plane. It ended up in the water, and unfortunately those people died. So in total there were 6 people involved in the accident, 2 vehicles, a plane, a car, and 2 deaths in total. That's the summary. So at first, the idea that immediately comes to mind is that the vehicle entered the runway and then the plane crashed into it. And then, well, there you go. That causes a loss of control, which is something that's pretty easy to imagine. All it takes is for a vehicle to crash, for example, into a landing gear or something else, and that can cause the plane to veer off its runway axis. This can lead to a mess, and it's not unusual. Remember, a few years ago, an Airbus A350, it was in Japan, landed on top of another plane. And it has happened quite regularly that planes land on top of others, or they almost did. The video from not long ago where we saw an E-jet plane with a Tunisian Nouvel Air plane flying over it, almost landing on top of each other as well. So today we have quite a few air traffic control problems around the world, and we keep seeing this kind of incident happening again and again. So it's entirely possible to think that the vehicle was hit by the plane because it entered the runway when it shouldn't have. But it seems, and we're still at the beginning, it happened a few hours ago, but apparently it had nothing to do with it, apparently. The vehicle was off the runway. There's a kind of path, a road around its perimeter, and there's regularly a vehicle that patrols. And at the moment the plane went off, it hit the vehicle. So I'll let you judge the likelihood of such a story. That is, it's 4 o'clock in the morning. A 747 is on a runway more than 3,000 meters long. There's a car that's outside. On the perimeter, the plane goes off the runway, it's going to hit the car and kill the occupants. It's quite extraordinary. Nevertheless, it's not a unique case. Remember, on this channel, we had a plane. It was in Taiwan. And what did the plane do? Well, it was, as I recall, an ATR loss of control because they had an engine failure and then shut down the wrong engine. So instead of shutting down the engine that had failed, they shut down the other one. So they ended up with no power at all. The plane went down, loss of control. It rolls onto its side. And what does it hit? Well, it hits a taxi. Okay, so it's not, it's a probability that seems low, but well, when you look back, well, it happened. It happened. Even before it happened, the probability seemed extremely slim. So, as I was saying, in this case, we have to think about the reason why the plane went off the runway. We have to exclude the vehicle in question from the equation because it hit it after it went off the runway, not before. So one of the options, earlier I was talking with a captain of a Boeing 747 whom I warmly thank for his help and for agreeing to discuss various scenarios with me and the thing that could be emerging. And once again, I want to add the usual precautions. We're a few hours ahead. It could be something else entirely. But there has been, with Boeing, pretty much we see this about every 2 or 3 years. We have situations with the nose wheel. The landing gear moves forward, if you will, the one that's located all the way at the front, which allows you to steer the plane. Well, on the ground, sometimes this one ends up hitting the stop all by itself. So how does it work? It works like this. We have the device, which is pretty much the same with just a few small differences. It's the same mechanism on the Boeing 737. There have been many 737-800 models. I'll show you one. It was in Canada where a plane went off the runway because of that. The same system is used on the 777, 747 and others, because quite simply, it's pretty traditional among all aircraft manufacturers. When they have an ingenious system to make something work, they tend to reuse it and duplicate it in other aircraft with a few minor differences. So the idea is like this. We have the nose landing gear, which is powered by a hydraulic actuator. Okay, it's moved left or right by one or more hydraulic actuators, depending on the aircraft. So it moves either way. The distribution of the hydraulic fluid, so the pressurized oil, is done through a kind of valve. Isn't that right? And this valve contains a moving part inside. This moving part is a spool system that's roughly the size of a cigarette if you want, and it only moves a few millimeters. Usually no more than 4 or 5 millimeters. So it moves one way or the other, and this will correspond to the movement of the landing gear in one direction or the other. It's made by Parker Hannifin, like almost all these devices on Boeing. So the story that happened in the past on other planes is this. You have dirt in the oil, so you have the hydraulic circuit and there's dirt in it. That can happen. Normally there are filters that catch that and everything, but there you go. Sometimes it can happen that small pieces of corrosion or after poor maintenance or something else, there is dirt in the oil. So dirt, if you want, the system tolerates it well enough. But sometimes we reach critical sizes. The critical size in this specific case is dirt or particles around 0 or 1 millimeter, 1/10 of a millimeter. So it's extremely small, but still visible to the naked eye. So look, a grain of flour is much smaller than 1/10 of a millimeter, and we can still see it. So it's very small. So what happens is that sometimes the drawer, let's say the drawer opens, and then the oil comes in and it brings this particle with it, and this particle will block the drawer in the open position. So this is how it happens for the pilot. For the pilot, it works like this. We have our pilot who lands and the speeds, and that's why I developed this hypothesis. It's because the speeds of the plane match this hypothesis. I'll tell you why. We have our aircraft landing, the pilots have no alarms, there's no indication of any problem whatsoever. The nose wheel is out and it's aligned, okay? So there's no problem. The aircraft lands, the nose wheel is down. At that moment, the pilots control their runway alignment with their feet. with the rudder pedals, which control the rudder, and also to a certain extent, a few degrees to the left and right, the nose wheel, okay? And at that moment, you can get some dirt coming into the system. So this is going to happen like this for the pilot. So either the pilot gives a push to the left rudder pedal, or the pilot who is pressing the right rudder pedal releases it. And in both cases, we have the valve system that directs the oil so that the wheel turns to the left. And if dirt blocks the open spool, it does this. The pilot, as I said, presses left or eases right, then feels the wheel turn repeatedly, and it will go all the way to the stop. So it will turn, and keep going until it hits the stop. Transport Canada, about a dozen years ago, recorded 11 different cases that happened on Boeing-type aircraft. So it's rare, isn't it? But as I told you, 11 cases over 20 years, we're talking about roughly one case every 2 years, on average. Okay. So the roulette spins completely. And here's where speed gets interesting. Do you know why? Because at first, if the plane is fast, if the plane has just landed and this happens, the pilots, thanks to the rudder, which has a high aerodynamic force, right, can still keep the runway axis, even if the nose wheel goes to the side. But when the speed drops, and that's what interests us, when the speed drops, there comes a moment when the rudder will no longer have enough aerodynamic flow. It will no longer be effective. And so what will happen is that the plane will start to respond more and more to the nose wheel, and at that point it becomes more effective. And so it slowly starts to come out. And that's why when you look at the graph of the rollout, it's not an aircraft that makes a sudden swerve. It doesn't spin around or anything, but it makes a very gentle curve like this, which gradually takes it toward the sea. So we realize that we're in a situation where there are two forces in balance, but one of them is starting to win. So it leaves the runway, it starts to leave the runway axis at about 90 knots, which is consistent with the beginning of a loss of control. It leaves the runway and hits the water at about 50 knots. So we're talking about 90 kilometers per hour, you see. So it's pretty consistent with this issue. The problem is that later on it's very difficult to investigate. Why? Because the position of the nose wheel isn't recorded by the black box. It's not recorded by the digital flight data recorder. And sometimes when the plane is recovered and we start to analyze the city circuits and all that, we find nothing. Why? Because it's some dirt that created a temporary situation, so it blocked that draw. But maybe 2 seconds before the impact, the draw had returned to neutral and the landing gear had started to come back. So when you analyze it later in terms of functionality and everything, well, it's normal and it's happened in other cases. That means the cases I told you about, which are mentioned by Transport Canada. When they analyze it later, they find nothing, just the system working normally. But how do we know? Well, what they do is they do a sort of, they take in quotes a mathematical pilot. That means they say to themselves, here is the trajectory of the plane. It's known and imposed, simple. What do we know? We put in everything we know. We know the position, for example, of the spoilers, whether they were deployed or retracted. We know the brakes. We know what pressure there was on a particular brake system. We know the thrust reverses, etc. All of that is known information. So now we say with all that, with this, the plane followed a certain trajectory. So what are we missing mathematically for this trajectory to happen? And at that point, we guess the position of the nose wheel. There's only one position for this trajectory, only one possible kinematics and movement. We use what we know to solve a complex equation by asking, given this knowledge, what don't I know? And from there, we manage to find what we don't know. You see, it's quite an ingenious method. And actually, it was used extremely widely at a time when the usual black boxes only had a few parameters. In the beginning, there was Aviation, and there was no black box. And then the first ones that came along had, when they worked, they had 5 parameters, you see? So there you go. Once again, to sum up, 747 Turks who worked for Emirates Airlines. By the way, on the radio, the call sign was the Emirates call sign, even though it was a Turkish crew Well, a crew working for a Turkish company and a Turkish plane. And so there you have it, the plane destroyed, the car destroyed, and unfortunately we have to report 2 deaths. So I'll give you more news the day the accident report comes out and we'll know more. He will either confirm this theory or go in a completely different direction. In any case, thank you for watching this video up to this point. See you in the next one, and thanks again to those who make this work possible through Patreon. See you very soon.